Dear student, good morning. Today we will discuss large sample test for equality of two population means. So that is, in this case our null hypothesis is H naught mu1 equal to mu2. So suppose there are two different independent samples selected from two different populations. See, there are two different populations and two different independent samples were selected from these two populations. So what is the constitution? See, there is a sample 1 and in this sample the size of the sample is n1, the population mean is mu1, the population SD is supposed to be sigma 1 and the sample mean is supposed to be x bar 1. And in the another sample, suppose if you take sample number 2 and in sample number 2, so there are n2 observations, the total sample size is n2, the population mean is mu2, the population standard deviation is supposed to be known and that is sigma 2 and the sample mean is x bar 2. So x bar 1 and x bar 2 are the sample means for the two samples. So that is sample number 1 and sample number 2. And in this case what we have to test is our H naught is mu1 equal to mu2 versus H1 mu1 which is not equal to mu2. So that means the population means are same is our null hypothesis, whereas in our alternative hypothesis we are saying that the population means are not equal. So that means this is the two-tailed test. And since we are testing population mean, so therefore our test statistic should be sample mean. And this is related with equality of two population means. So that means our H naught is mu1 equal to mu2, that is mu1 minus mu2 equal to 0. So a test statistic is based on a difference between sample means, that is x bar 1 minus x bar 2, since our H naught is mu1 minus mu2. Therefore we are taking the difference between sample means. And clearly we know that x follows normal with mean mu1 and variance sigma 1 square, and the second one is x2 follows normal with mean mu2 and variance sigma 2 square. Clearly our expectation of x bar 1 minus x bar 2 is mu1 minus mu2, and variance of x bar 1 minus x bar 2 is variance of x bar 1 plus x bar 2 plus 2 times covariance, and this comes out to be sigma 1 square upon n1 plus sigma 2 square upon n2, whereas this covariance term, since both the samples are independent, therefore covariance between x bar 1 and x bar 2 is 0. So this comes out to be what is variance of x bar 1 minus x bar 2, so that is sigma 1 square upon n1 plus sigma 2 square upon n2. And as per the central limit theorem, so our z statistic value becomes, so this is x minus expectation of x divided by standard error of x. In this case my x is x bar 1 minus x bar 2. So my x in this case is x bar 1 minus x bar 2 minus expectation of x is x bar 1 minus x bar 2 divided by standard error of x is x bar 1 minus x bar 2. So expectation of x bar 1 minus x bar 2 is mu1 minus mu2, and the standard error, since we have calculated the standard error value, so that value is sigma 1 square upon n1 plus sigma 2 square upon n2. So therefore what is my z statistic in this case, since it is a large sample test? So x bar 1 minus x bar 2 minus mu1 minus mu2 divided by square root of sigma 1 square upon n1 plus sigma 2 square upon n2, and it follows a normal with mean 0 and variance 1. So friends, this standard error is nothing but square root of variance, and we have calculated variance of x bar 1 minus x bar 2. So take only the square root of this, so that will gives us the value standard error of x bar 1 minus x bar 2. And since our test statistic, which is the test statistic is x bar 1 minus x bar 2, since our population we are testing the population as H naught as mu1 equal to mu2. So therefore under H naught mu1 equal to mu2, So Z is, see, in this case H naught is mu1 equal to mu2, so that means mu1 minus mu2 equal to 0. So suppose if you put the value of mu1 minus mu2 as 0 in this case, so now the revised Z under H naught becomes Z is equal to x bar 1 minus x bar 2 divided by square root of sigma 1 square upon n1 plus sigma 2 square upon n2. This follows normal 0 1. In any testing procedure, dear student, we have to follow a 4-step procedure. The first step is setting up the null hypothesis and the alternative hypothesis. The second is we have to find out the test statistic. In this case my test statistic is Z. See, this is my test statistic, Z value. The third step is related with critical region. Since my alternative hypothesis is two-tailed, therefore I have to employ two-tailed test procedure. And in two-tailed test procedure, so our value, the table value can be obtained such that probability of mod Z is greater than or equal to Z alpha by 2 equal to alpha. So you can take alpha as 5%, 1% or 10%. And if your calculated value of Z is less than table Z, then you have to accept the null hypothesis, otherwise we have to reject the null hypothesis. So these are the 4-step procedure. First, set up the null hypothesis. The second is find out the value of Z, so that means the test statistic. The third step is related with critical region, and finally you have to conclude with the procedure. So that means we have to accept or reject the null hypothesis. So thank you very much.